Hi everyone, I'm Curran. If you have a laptop with you, I would encourage you to open it up and follow along. This will be very JavaScript heavy, and I'm going to go through a lot of JavaScript examples to sort of show what this project chiasm is all about. And I'm assuming that you are all fairly well versed in JavaScript. Like, this talk is really for people who know JavaScript already, and maybe you've used D3, so be warned. So I guess I'll just, show you the project page just briefly to get a sense of the project. So it's this open source project. I started it about 7 or 8 months ago now. I designed it during my PhD work at University of Massachusetts, and now I got to build it at this company, Alpine Data Labs, over the past 7 months. And so there are all these different examples that show you, like, here's one example where one component is a leaflet map and the other component is a D3 globe, and you can interact with both of them, and as you zoom in and out in the map, it updates your location over there, and you can use the D3 globe to control the map. So this is showing, like, integrating two different technologies into this component framework. So that's the whole idea, and also linking visualizations together, where you can interact in one visualization that affects another visualization. But what I'm going to do now is sort of break it down to the basic beginnings of a JavaScript program, and then go from there and build up more and more complexity until we have some linked views. And you can see all the different patterns in play in this library, this framework, this whole idea. So first of all, what's the point of chiasm? There are two main points. One of them is it's a component framework where you can define your own components for interactive graphics, data loading, data transformation, and data visualization. But it's open-ended. You can make more components for all kinds of different things. And then it's an application platform. And by application, I mean a set of instances of components that it manages for you. And like, maybe application is too broad, maybe more like, visualization dashboard would be a better term. I don't know. But, chiasm basically instantiates and configures components for you. You can use this to map data to visualizations. So you don't really have to write code. You can just configure these generic reusable visualization components with your data. You can respond to the browser resize, and you can link visualizations together. So here's like the starting point of this session. It's a Hello World program that uses Browserify. And so there's a main program here that gets the element with the ID output and sets its inner HTML to Hello World. And here's the index.html. It's like a Hello World HTML with an H1 element here that has an ID output, and then it loads this main build JavaScript file. And the main build is different from main. It's this thing that's kind of ugly that's generated by Browserify. So what Browserify does...
Can I ask why there's a double hyphen there in the main build.js? Is that a typo?
Oh yeah, well, I made this little viewer script hide main dash build in all the other examples because it gets bigger and bigger.
Okay.
So it's just, I named it so that you can see it here. Just so, yeah, it's not the actual... Yeah, it's a little confusing, but like, just so you can see that the fact that it's a built file. So in the future examples, you're not going to be able to see the main build. I just wanted to show it here. That's why I added the 2 dashes. So it's like some ugly stuff that's like, legit JavaScript. You just have to trust Browserify that it does the right thing. So what Browserify does is it lets you use the node module system. So I did it this way so that I can have lots of modules, and then the node require syntax. I can use that to manage the dependencies and not have like loads and loads of script tags on the page. So there's a package.json which comes along with the node environment. And so it's just like I ran npm init and just like went through the fields. And to build this, so if you want to go into this code in the future, you can go into these directories in the GitHub repository for this. You can run npm run build, and then it will execute this command, which will generate the built file from the main program. So this is our starting point. And from here, I'm going to add incremental changes. So here's one incremental change that it's using dynamic HTML. So there's some JavaScript like set interval. So every second, every 1,000 milliseconds, it calls this function, and it says inner HTML is count plus plus. So this is just demonstrating like using Browserify and also manipulating HTML. So introducing model.js. So model.js is this open source library that I made about a year ago when I was doing my PhD. And it lets you build these reactive data flows. And this is basically the syntax. It introduces this win function, model.win. And it's kind of like the dependency injection syntax from Angular or from require.js. So these are the model properties, and whenever both of these are defined, and whenever either of these change, this function will get invoked with the new values for these two things. And then you can set model properties just as though they're JavaScript object properties. So model.fullname equals something. And you can chain these things together. So you can have like x, whenever x changes, update y, and then whenever y changes, update z. And this is like a visual representation of these data dependency graphs. So model.js is it's not that big. If you look at the source code, it's like, I don't know, 200 lines or so, and a lot of those are comments. And so this is what I'm building off of to build this chiasm project. So here's one example of how you can use it. Require model-js, that's the name of the NPM package that you can install through Node. And then make a new model. And then I've adopted this convention of using my for the model instance. And then you can use win, my.win count. So whenever the count property is defined and whenever it changes, this function will be called with the new count. And then this function is changed so that every second it says, you know, my.count gets incremented. So it's introducing a model layer into the whole situation. So it's very similar to Backbone in many ways. It has an on function, it has an off function, just like Backbone. Have you guys used Backbone? No? So like Backbone is really great. This is like before Angular, before React. This was like, I don't know, maybe 2 or 3 years ago. This was like the big wave of like, oh, you can do a single page application and everything like that. And so Backbone has this model class, which is the inspiration for model.js. I was actually using Backbone before for visualizations, and then I ended up implementing that when function in different variations on top of Backbone. And then I realized, well, that's the only thing I'm using Backbone for, so why not just make my own thing that's actually really small, a lot smaller than Backbone. So this is the concept of model.js. And we'll see more of its API as we go forward. Like here you can see I'm passing in just a single string. And there's a variant of this where you can pass in an array and with multiple properties. And you can also pass default values into the constructor, similarly to Backbone. So yeah, that's model.js. Introducing model.js. Yeah?
You know how you said that you can initialize? Could you initialize count in there and then not define it?
You could. Yeah, instead of saying my.count equals 0, you could remove this line right here and then put it right here instead. That would work. That would work. Yeah. So hello D3. This now I'm introducing D3 into the mix. So if you use, so I'm using D3 as an NPM package and then using Browserify to bundle it up. But I'm using this other thing called Browserify shim to actually exclude D3 from the bundle, because if you include D3 in your Browserified bundle, it's like, I don't know, 300K or something. It ends up being like this massive bundle. So rather than doing that, I'm excluding D3 from the bundle and then including D3 on the page through a CDN like this. So with D3 in the mix now, whenever the count changes, this is pretty much the only line that's different from the previous example. It uses it's using D3 to select the output element, and then D3.select the thing with ID output, and then .text equals count. So it's putting the count into this DOM element every second. So here is how you can use D3 and model.js to create components. This is the basis of the chiasm project. Like, this is the fundamental pattern of the project. So you require model and D3, and my component is a function. It's a constructor function for components. So the component instance is a new model. And then this is like more of a convention. It's not like a part of any library, but it's a convention. My.el. L stands for element, as in the DOM element that's going to be managed by this component. And this is inspired by backbone views. Backbone views also have this notion of a view.el. This is a DOM element that gets created and it always exists, and then you can append it to the page. So my.l equals document.createElement in h1. My.count equals 0. And like you said, you could pass this into the constructor, either way. And then when the count changes, select my element, which is a raw DOM element, so we need to pass it into select if we want to use D3 functions, and then set its text to be count. And then this component has this behavior of updating the count every second.
If you did put arguments or a hash into line 4 as the argument, where is that going to be assigned to mine?
If you wanted to have a component where you could specify the initial count, you could totally pass it into the constructor.
Okay.
Yeah, definitely.
But then I don't see where it would get assigned to mine in this.
Well, you could do it something like this. Initial count, and then in here you could say, or,
Initial count or.
actually down here you could say like this, my.count equals initial count, like that.
Okay.
So you're just assigning it to a property on the model, if you wanted to do that. And we'll see going forward how we can have properties that you can set externally. But then, if you wanted to set it, you could actually construct the component and then say, my component dot count equals something, and set it like that after the construction happens. That could work too. So in this case, to use the component, we say, my component equals new uppercase my component. So I'm using this convention of lowercase as the instance and uppercase as the constructor. And then get the element that is a container. So I changed this to be a div that has an ID of container. So you get the container and append this component element to that container.
If you didn't put a new on line 21, would you still get the same result?
The way that I've made it, it doesn't matter. You don't need new because I'm not using this, the this keyword.
Right, you're returning the object that you're creating.
Exactly. And also, you don't need new here. I just put it there because it looks, professional. But model is a function. It doesn't use this. So model.js does not use this and new.
To me, it's confusing to put the new in. It's like get rid of new.
Yeah. I have this. Yeah, I go back and forth. I mean, I want to get rid of new. I never want to see new. But if I don't put it there, some people are like, well, why don't you have new? You're constructing a new thing, So it's like, I put it there just to sort of go along with these old conventions of using new. But yeah, the library, I have an aversion to using this and new because you have to like bind things and it gets all confusing with the callbacks. So throughout the chiasm stuff, I'm not using this and new at all. So this is the basic component pattern with DOM elements and models.
Could you use d3.select container?
Oh yeah, you could, but you would have to say d3.select hash container .node to get the DOM element because this append child is not a D3. This is a DOM element function. So that's why I didn't use D3 here because it would look a little bit different. It would be like d3.select, hash. See, when I use the arrows, it goes back between them. But yeah, you could use D3 there too if you wanted to. Yeah. But D3 is not for setting numbers into H1 tags, right? It's for really manipulating SVG. This is like the most common use case for D3, and this is how you create visualizations. So here's one example of a component where we say document.createElement NS. This is necessary because it's SVG. It's sort of a quirk of SVG. You can't just create an SVG element, otherwise it doesn't render. It has to be namespaced, which it's just a weird thing, you know. So creating an SVG element, setting the width and height to be this fixed 200, which we want to change, but I'm just doing it, you know, just so you can see what it looks like. So we're creating an SVG element, and then we're appending a rect element, a rectangle, using the D3 syntax, svg.append rect. So we're creating this rectangle that's 200 pixels by 200 pixels. And then everything else is the same. We're appending this element to our container. And this is what the container looks like. But the problem here is it's a fixed size. And what we really want, I mean, whenever I make a visualization, the first thing I want to get it to do is like resize to the browser. You know, because all these D3 examples, when you see them, it's like, oh, width 960, you know, 500. Like, they're all the same. It's all hard-coded, you know. So one of the goals I wanted to address with this, you know, these projects is responding to resize and having visualizations that will easily resize to wherever you put them on the page. So lifting the box. So like so I go through this process a lot of making things configurable or putting them onto a model. And I like to think of this as lifting the properties. So there's this box property, which is like width and height. And so I think of this as lifting it into this model space, you know, as a property on the model, lifting it into this new realm where you can use the when function and respond to changes and also set it. So here's what the component looks like now. my.when_box. So whenever the box property changes, this function gets called. And box is going to be an object that has width and height properties. And these are width and height in pixels. And so you can set, you know, dynamically set the width and height of the SVG and rect tags based on this. So that's what the component looks like. But then when you use the component, you need to set the box. So here the box is being set as like a hard-coded value of 200 and 50. So it's 200 pixels wide and 50 pixels high. So we're getting there. Like now box is a configurable property, and if you set it, it will update the DOM elements. But it's being set to this hard-coded value, right? Ideally, this would be set dynamically based on the page. So in the next example, we're responding to resize. So,
Can I ask, when you
yeah.
set the width and height in that previous example towards the bottom?
So there's this my.when_box. So whenever the box property changes, this function gets called, right? And the box property is really only changing once when I set it right here. So this function is only being called once. And then when this function gets called, this is the D3 syntax now, .attr, setting the width and height attributes together at the same time. And so that the way that the browser rendering happens is that the actual rendering cycle, like rendering the DOM elements to the screen, it happens only after this function exits, because it's deferred until the next tick of the JavaScript event loop. And so even no matter how many properties you set, if you do it all in sequence like this, in one like control flow, the rendering gets deferred until the next tick of the JavaScript event loop. So there's actually one rendering happening right here.
You did it right. Thank you.
Great. Great, thanks. Are you like quizzing me? All right, so to respond to resize, what I'm doing now is we've got this container div, and I'm using CSS here to set its size as position fixed, meaning like relative to the page. And this is a little iframe, by the way, that's displaying the example. Left, right, top, and bottom are the margins. So it's going to be like 10 pixels away from the top, bottom, left, and right. And its position will be fixed. And this position is computed by CSS. And in order to get that position out of the DOM, like the rendered DOM computed by CSS, you can use this property on the DOM elements called client width and client height. And so when we're instantiating the component now, we're getting the container div, appending the child just like before, but then there's this function now, update box. So my component.box equals, an object with width and height equal to container div dot client width and dot client height. And so we call this once here to initialize it, and then every time the window resizes, we're adding an event listener to the window object, it will call this function update box and update the model, which will in turn update the SVG elements. So we can see how it responds to resize if we open it full screen here. But you see when I resize it, there's this little lag. So that's like, it's just a property of the way that we're doing it. Because the model.js defers the execution of these listeners until the next tick of the JavaScript event loop after the property gets set. So there's that little bit of a delay where you see that white area in the corner. But it basically, it's eventually consistent, right? As they say in like NoSQL databases. So when I say listener, I mean this function here that gets called in response to the box property changing. And so model.js manages when these get invoked. And the way that model.js works is if you say my component.box equals something and then something and then something all in one flow, only after that execution ends, like at the next tick of the JavaScript event loop is when model.js will invoke this callback. So there's a little bit of a delay with model.js. And that's like kind of a flaw of model.js. I wanted to address it, but it's just how it is right now. It's essentially using the JavaScript event loop as a queue for a breadth-first search propagation of these changes through this dependency graph. Right, so this is how you can respond to resize, and it works. And so let's add a color property. So how would we do this? So I'm passing the default color here into the model constructor. It's going to be green initially. And then I'm adding a my.when listener here. So whenever the color property changes, this function gets invoked, and then it uses D3 to set the fill attribute on the SVG rect element to whatever that color is. And then there's a little piece of code here that says, after 1 second, set the color to be red. And then after 2 seconds, set the color to be blue. So if I navigate back to it, it's green, and then it's red, and then it's blue. Right? And so what's cool about this is you're just setting the property on the component, and then model.js is propagating that update through the system. And so let's take it a little bit further. Let's make it interactive. So now when I click on it, it sets the color to be a random color. And the way that looks in the code is rect.onClick using the D3 syntax. So whenever I click on a rectangle, it will set my.color equals a random color. And here's some code that generates a random color. So this is how we can add properties one by one. So now introducing chiasm. What is chiasm good for? So all right, we're going to require chiasm using the node require syntax. It's a node package, an npm package, so you can require it like this. You can do npm install -s chiasm, to add it to your environment. And what it does is it manages instances of components for you. And so here's how you use it. You say, var chiasm, the chiasm instance, the new chiasm. Again, you don't need new actually. It's constructing a new instance of this runtime environment. And then chiasm.plugins is a special object where you can assign properties to it that correspond to these component constructors. And then In my head, I've been going back and forth between the terminology of plugin and component. I'm not sure exactly what's a plugin, what's a component, but as far as in my conception of things, as soon as you add it to the chiasm.plugins property, it becomes a plugin. A plugin is really a component, though. It's just added into the chiasm environment. So once you've added it here to chiasm.plugins, you can reference it in the chiasm configuration, which you can set by calling chiasm.setConfig. My component, so the keys of this top-level object are just aliases. They're like names for the instances of the components. So my component, the plugin is my plugin, so that tells chiasm how to construct, like which function to call to construct the component. And then the state is another object that has keys and values, and these get transferred in as model.js properties. So the color gets set to blue. Notice that the default color here is green, but then chiasm will propagate this blue color into the model and then through the SVG. And you can see it's blue. Yeah?
Doesn't it seem like there's some duplication of syntax? 34 is saying you've got plugins with a my plugin that's related to my component, and then on line 37 and 38, you're basically repeating that same information.
Right. Yeah, in these small cases, there is a lot of duplicated strings that you have to type over and over again. It's unfortunate, but it's sort of...
Other toolkits have that same problem.
Yeah. Yeah, I mean, in this simple case where there's just one thing, it really seems like, oh, there should be a simpler way. But I've kept it in this verbose format to support scalability, and I think we'll see later, because the reason why this and this are different is because you can have two instances of the same plugin, two instances of the same component in the runtime environment, and they need to have different aliases. And my component could be anything, and it could depend on the application. It could depend on the scenario. This is like a variable name. Yeah. And then what am I doing here? Right. So this is like the bare bones of what chiasm does. And this bit of code here is how you can get the instance of the component out of chiasm. So you can say chiasm.getComponent my component. And this returns a promise, a JavaScript promise, which is an asynchronous construct. And so you can call then on the promise, which will give you this component. And then once you have the component, this is all the same code as before that adds it to the page, appends the child to the container, and then updates the box accordingly. And this is here, in future examples, this code will go away. But I just put it here so to communicate how you can get things out of the chiasm environment if you need to. But this logic can be encapsulated itself into a component. And so here's what that would look like, componentizing the layout. I'm calling it layout. It's really just appending the DOM elements for the components to a container. So the component itself is the same. I can click on it. It changes color. So here's this simple layout component. And notice that it actually takes as an argument the chiasm instance. And so this allows chiasm components to actually manipulate the chiasm runtime, like change the configuration or extract things out. So this is what the model of the layout plugin looks like. It's got a container selector and a component alias. And I'm introducing a lot of things at once here, but just bear with me. So chiasm has this notion of public properties. In order to be configurable in that configuration, and actually in the previous example I added it, I forgot to mention it, but there's this public properties thing that needs to be a property on the model. And this declares it declares the set of properties that you're allowed to configure through the chiasm configuration. And the reason why this needs to be like this is because at the time the component is constructed, chiasm needs to know the default values for the public properties, because they may be omitted from the configuration. So if they're not included in the configuration, chiasm needs to know what the value should be. you know. And there could be a situation where you can set the property of it in the chiasm configuration to a certain value, and then set the chiasm configuration to a configuration that doesn't have any specified value for that property. So then chiasm needs to reset it to its default value. And this was a tricky thing that took me a long time to figure out, but it was, the whole system was unstable, because like what I wanted, the whole goal of chiasm is to be able to set the configuration over and over again at runtime dynamically, and then it detects the changes and then propagates the changes through the system. And so it was unstable without this strict notion of public properties that need to have default values. So this is how chiasm expects public properties to be declared. A special property on the model called public properties, and then each one of these strings corresponds to a property that needs to have a default value at the time the component is constructed. So, and then there's an issue where, what if you have a property that is optional, and if it's not specified, you don't want to have it really have any behavior, but it has to have some value, and that's why there's this notion of model.none. This is similar to the option type in Scala. So like these functional languages have this notion of an option type, where there's something that's defined, but it's optional. Like it might not really have any meaning, but it's not null, it's not undefined. So model.none is just a special value. It's just a special string, really. But it's like a convention in this world of chiasm stuff. So when there's the container selector and the component alias, and they're both not equal to model.none, then get the alias out of chiasm. Sorry, let me orient you to what these actually are in the configuration. So the container selector is, container. This is the thing that we want to inject the components into, the container on the page. And then the component alias is the name of the component that we want to inject onto the page. And so over here we can get the component out of the runtime and then append it to our component, which we can select dynamically based on the selector. And then the update logic is the same. But with chiasm, you don't even have to implement this, because there's there's this sub-project under github.com/chiasm project. There's a bunch of little sub-projects, and one of them is chiasm-layout. And this is like a sort of more hardened version of that layout plugin that we just saw that does nested box layout. And so you can use this to have multiple components on the page and then arrange them in a nested box kind of a structure. And this is what it looks like. It's a tree data structure in JSON where these strings refer to the IDs of various components that are in the configuration. So here's how you can use it. I'm requiring chiasm-layout up here, chiasm-layout, and then instantiating that, and layout, the layout property is my component. And this is sort of a degenerate case of a more general structure. So in the next example, we see the nested box structure in action. So this is what the configuration looks like in this case. There's an instance of the layout plugin that has a container selector as my container, and then the layout property is this tree data structure that says, okay, the top level is a vertical split, and the thing on the top is A. This white one is A. And then the thing on the bottom is, something that has a horizontal split, and there are, these children, B. There's 3 children, B, this thing that has a vertical split with 2 things inside of it, and then E. And these A, B, C, D, and E are all just instances of this myPlugin thing, this colored rectangle, that are configured to have different colors. And then they retain that interactivity, so when I click on it, it will change color. So I think I skipped over something. Yeah, chiasm-component. So this is another sub-project of chiasm that's a thin wrapper around model.js. that gives you sort of convenience functions for dealing with public properties. So you can create a chiasm component, and then the things that you pass in here to the constructor of chiasm component are added as public properties to the model. And so what that looks like when you define your own components, you can say, instead of having here, public properties equals an array that has this one thing in it, you can just pass the color is green into the constructor of chiasm component, and it will make whatever you pass into here, it will make them public properties that you can configure in the chiasm configuration. Yeah.
So you wouldn't use a chiasm component if you wanted some property to not be public?
Oh, you would still use it, but you just wouldn't pass those properties into the constructor. For any properties on the model that you want to have that are not accessible in the configuration, and there are many use cases for that. You just don't include them in the constructor. Yeah, it's just a convenience way of declaring the public properties up front. And chiasm component, it also gives you a function add public properties or add public property that takes as input the property name and the default value. And we'll see that a little bit later. So these are just, if you see chiasm component itself, it's really small. It just has some convenience functions for dealing with public properties. This main program has the component and it has the chiasm application. So what I'm going to do next is just split these into separate files. So now there's a main.js, which is the chiasm application, really. It's just, creating a new instance of chiasm. And now I've switched it around to do something that you can only do with Browserify and Node.js. I'm using this require syntax in one line. It's not up here, but it's, in the code. So what this lets you do is have one line for adding a new component to the runtime environment, making it available to configurations. And I just wanted to do it this way so I can add more and more things, and each one will just be on one line. So this is the application, and then there's a mycomponent.js file, and this is a chiasm component, right? So if I click on it, it changes color. It's still there, all the same behavior. And I made this shorter. I made it 2 lines instead of like 10,
Back to the top of that file where you had the requires, I call them in line on line 6 and 7.
Yeah.
Could you put those on line 2 and then reference?
Oh, yeah. So in the previous example, I was doing that. Yeah, like chiasm-layout up here, and then again down here.
I've used another big toolkit where people put this stuff in the middle of the code. And if I write the code, I like doing it that way. If I have to read somebody else's code, the bar statements at the top.
Yeah.
So to me,
Yep.
I don't know, I hate to argue here, but to me, it's better programming practice for readability too.
Oh, sure. Oh, yeah. I mean, it's always a trade-off, right? It's always a balance. It's like a stylistic thing. But, yeah, definitely. I mean, you could... And if you're using other things like browser globals, you have to have script tags. If you're using ES6, you have to have everything in the top of the file. I just did it like this so that the logic for requiring a new component is just on one line. So we can add more and more things, and it's easy to add and remove them. But yeah, there's arguments to be made that this should be at the top of the file. Yeah, totally. Right, so this is like the basic, a basic chiasm application with one component. It's a rectangle that changes color. But how you guys doing? You following? Is it too intense or? You good? Great. So here it's just a slight variation that uses add public property, and I put this group of code all together to show that this chunk of code represents the logic of having a rectangle that when you click on it, it changes color. And so rather than having the public property in the constructor of the chiasm component, now it's using this thing add public property. And this function comes from chiasm component. So it's saying, okay, I have a background rect color. I changed it from color to background rect color because we're going to have a lot more properties. And it's going to be like, we have to sort of be careful with the namespace. So the default value is white. And then all this stuff is the same as before, but I've just grouped it all together like this. And when I see things like this that are easily grouped together like this, you can pull it out into a separate piece. And so I'm calling these reactive mixins. You know, it's just sort of something I made up. I don't know if it's like legitimate. But so here's the component itself. And we can call a function background rect, give it the model, you know, the component instance, and the SVG element. Oh, and chiasm component also gives you this function called init SVG that creates an SVG element that you can use. It's actually an SVG group element because the chiasm-layout plugin will manage a single SVG element, and then each component will be in group elements. So this is so you can have multiple visualizations, and they will all be within one big SVG element. So you can export that SVG data for printing, something like that. So that's just a small point, you know. But yeah, background rect is now a function. Yeah.
Is it restricted to being in SVG, or is it just because of the convenience of printing?
It's just because of the convenience of printing. And like we had this need to be able to export a set of visualizations as an SVG or as a PNG. And that was easier to do. Like, actually, let me just show. With this example with the nested boxes, if we view this as full screen and then we inspect the DOM, you can see that there's one SVG element that has everything inside of it, and then each one of these rectangles is a group element. But you can have divs also. And so the chiasm-layout plugin annotates the DOM here with this verbose class that doesn't do anything with CSS, but it's just for developers who are inspecting the DOM. So all the SVG elements get put inside of here, but everything else gets put inside this div. But they get positioned correctly. And so with the leaflet example, the leaflet map, that was using a div, not SVG, and that can also work. So yeah, anything that can fit in a div, you can have it as a chiasm component. But I just made this special case for SVG because it's the most common case. Right, reactive mixins. So notice how all the logic for this background rectangle can now be put inside of this function. Whoops. So adding the public property with the default value. And this is also dealing with the logic of appending a rectangle to the SVG element. And then reacting to the box, reacting to the color, and reacting to the clicking. It's pretty cool, right? So it gives you a way of encapsulating this sort of reactive behavior as these mixins, you know, reactive mixins. And with this sort of pattern, you can do things like encapsulate the D3 margin convention. So who's familiar with the D3 margin convention? So let me just cover that a little bit. The D3 margin convention is something that comes up in just about every single visualization that has an X and a Y axis. You know, it doesn't come up for like a pie chart, but you know, for most visualizations, this comes up. And the way it, you know, the whole thing that this does is it has this inner box for the visualization that's smaller than the outer box that contains the whole SVG element. And this is so that you can have things like axis labels, you know, axis labels and tick marks outside of this margin. And so it looks like this. You define the margin as top right, bottom left in pixels. And then you have a group element that you need to translate by the margin left and the margin top. And then also you need to compute. See, here is again hard-coded 960, 500. I hate that. But this so in the margin convention, width and height, these names, it represents the width and the height of this inner rectangle, not the outer rectangle. And so this translates really nicely into this world of model.js and reactive mixins and things. So here's the background rect as a function, and here's the margin convention as another function. So This is appending a group element. It's adding a public property as of margin, and this is the default margin. You know, just drawing from the structure of the D3 margin convention. And then whenever the box from before, the outer box, and the margin, whenever the box where the margin changes, you know, call this function with the box and the margin, and then set width to be the outer box width minus margin left minus margin right. And this line of code is very similar to that line of code that's in the margin convention original example. And then set the height, you know, similarly based on the box and the margin, and then transform that inner box by, you know, margin left, margin top.
Okay, so I'm going to be a pain in the ass.
Yeah.
Somebody can execute me. On lines 29 and 30, you're setting dot width and dot height. In your first example, you said, hey, by having an object with a width and height property, we're only going to draw a rectangle once. Now I'm going to go back and be a pain in the ass. How many times are you going to update or redraw? Because we have observers to width and height now.
So, to answer your question, both of those things are coexisting in this example. Because box is a property. Box here is an object that has width and height. Box.width, box.height. This is the same exact thing that we were using before. And there is a slight discrepancy where I'm using an object with width and height for the outer box, but I'm using properties width and height for the inner box.
And I wasn't listening to you because basically you're going to delay executing the changes until dot when completes, right?
So yeah, like box and margin are set already. Oh no, box gets set later. Yeah, so after box gets set, and on the next tick of the JavaScript event loop, after the box property gets set, and the margin property is already set, then this function gets executed. Yeah, so there is a slight delay. There is. But it's the same delay as when I click on it, it sets the color. It's negligible.
But then on lines 29 and 30, what prevents you? There's a listener to my.width, right?
Not yet.
Not yet?
Oh, actually, yeah, I did. I didn't cover this part of the code yet, but I added this thing, margin rect, which is basically a copy of background rect, but it's inside the margin. And so my.when width and height. So this is listening for the width and height and setting this inner rectangle based on that. So there's the outer rectangle and then there's the inner rectangle. Yeah. So you set, box gets set. The next tick of the JavaScript event loop invokes this function, which sets width and height on the model. And then the next tick of the JavaScript event loop after that, the next listener gets invoked, this one here, that sets the width and height of the actual rectangle. So that is a deficiency of Model.js. Like when you get data dependency graphs that go for like 10 or 20 hops, it takes 10 or 20 ticks of the JavaScript event loop before the last one gets executed. But in practice, the data dependency graphs for visualizations are not really that deep. They're maybe like 4 or 5 hops away from when you change the configuration to when you render the chart. So in practice, it's negligible so far, but I wanted to try to address that. But that's like, so I did make this thing, I don't know if I should go into it, but this library called reactive-model, which is like, I tried to redo model.js with this in mind, and I tried to improve the performance so everything is synchronous. So this version of the library does an actual like depth-first search algorithm on an explicit graph representation of the dependency graph of these properties. But this library is a lot more lines of code than model.js, and I'm not sure it's 100% correct. So I'm not using it. But yeah, your point is totally valid. Yeah. But yeah, I think it's a small price to pay for the ability to separate things out and organize the code in this way with these mixins. Right, so now we've got a margin, which is like the basic building block for most visualizations. Let's add an axis. So in this example, there's now an x-axis on the bottom of the box right there. And this is also done with the same pattern of this reactive mixin. So here's the component. And actually, we haven't looked at this part for a while. So it's creating the background rect, and then it's using the convention, the margin convention mixin, which returns that group element, and then it calls margin rect on that. So these reactive mixin functions, they're creating DOM elements, and they're also adding these win listeners to the model. And then here in this example, there are two more. The x-axis linear, because the code would look different for ordinal or time scales. So I'm just doing it for a linear scale first, and then the axis. And so let's look at these one at a time. So here's x scale linear. It takes just the model, or the component, the instance. It creates a new scale, which is in the closure of this function, and then adds a public property, the x scale domain, and it's set to a default value of this array, where the first thing is the minimum value and the second thing is the maximum value. This is a convention from D3 for representing the domain of a scale. And so my.win, x scale domain, and width being the width of the inner box inside the margin. So whenever those two change, set the domain to be that domain, and set the range to be 0, width, which is the domain of the x scale in most visualizations, starting at 0, going to the width of this inner thing. And it sets my.xScale to be that scale. So now other functions can listen for changes in the x scale, and then when the x scale gets set, the domain and the range are both set, so you can actually use the scale. And so the x-axis mixin looks like this. It appends a group, gives it a class of x-axis, so you can use CSS on it. It creates an axis object with D3, a D3 axis. So whenever the x scale changes, it sets the scale of the axis to be that scale. And then it calls, so this is all like standard D3 patterns. So it says x-axis-g.call. So x-axis-g is a D3 selection on this group element that was added that will contain the axis. .call axis, which will create the tick marks and the labels for the tick marks. And then also, in response to height, it will transform this x-axis group to be on the bottom. And without this line, it would appear on the top, which we don't want. And this, again, like if you look at any like bar chart example or whatever, like you see these lines of code, but they're all like in sequence. So you just do them once, and then like you have to really rip apart the code in order to make it dynamic. But this way of structuring the code is is like reactive and dynamic. So I can do things like, if I open it up, let's see, open as a new window. If I open it up like this and I resize, you see everything is responding to the resize. And you see there is a slight lag, and that slight lag is caused by the issue that you brought up of the fact that the when executions are deferred. And so this is the kind of performance, this is the kind of behavior that you see. It's not perfect, but basically works. So yeah, in the next example, I want to make the tick marks based on a density specification, because if we open this, all right, if we open this example in a new window, and then we squeeze it to be really small, you see how the tick marks get closer and closer together? And if I could make it smaller, they would start to overlap. And so for resizable visualizations, I found that what you really want is this density-based tick marks. So this is the kind of behavior that I think is preferable for resizable visualizations. As the axis resizes, the tick mark density should remain the same. And this is not something that you get in D3. You have to sort of program this yourself. But it's fairly simple. You just set the number of ticks to be width divided by the tick mark density in units of pixels per tick mark. So this pattern I have put into this environment of chiasm and things. And so in the x-axis, we're introducing a public property called x-axis tick density. So there should be approximately 70 pixels between each of the tick marks. And then when the scale changes and the density changes, and we need the width also to do the computation. And so that's one beautiful thing about model.js is whenever you need something, you can use the syntax to just get it out of the model. And so now this is a new line of code that says, the number of tick marks should be approximately width divided by the density of ticks. And so if we look at this one in a new window and we resize it, you can see that the tick mark density stays the same. See that? So now let's add an axis label. So these are just tick marks, but we don't know what does this axis really mean, So let's add a label. So x-axis label, this will change depending on the data, but it turns out this is actually a chunk of code, So this can be a separate reactive mixin from the actual axis. So now back in the component, we're adding an x scale, the x-axis, which returns now, I've made this function return the x-axis group, so we can add the label to it. So then when we call x-axis label, we give it the model and also this group element. So the x-axis label, now this has all the logic that just pertains to this little label right here. And so I'll just go through it. We're adding a text SVG element to the x-axis group, and then we're giving it a class, so you can apply CSS to change the size and stuff. We're adding public properties for the actual text, which is x-axis label, and this is something we can change, at runtime. And then the text offset is 43 pixels south of the actual line of the axis. And so when the text changes, we just say label.text, with the new text. And then when the offset changes, we set the y property, the y attribute of the SVG element. And then with the width changes, we set the label to be at width divided by 2, which is the center. So this, if we open this also in a new window, it has all the nice resize properties that we want. See, when we resize it, it stays in the middle. Cool. So we can do the same thing for the y-axis. I don't think I'll really go through the code, but it's the same pattern pretty much with some quirks to do with the fact that it's vertical. You have to rotate it. But, it's nice how it's a separate reactive mixin. Here's the mixin for the x-axis label. Here's the mixin for the y-axis label. And so, yeah, this is the only thing that's significantly different. We're dealing with the x and y together here as a transform on the element. And we need to do it this way because we're rotating at 90 degrees. And so that's how the text is, sideways. And this is what the component looks like. These nice groups. We're creating stuff, we're creating the x-axis, we're creating the y-axis. So this is now what the component looks like. And this is a good baseline for creating a bunch of different kinds of visualizations. But first, we can refactor it a little bit. So here's my component.js, but it really has all these functions that are these reactive mixins that can stand on their own outside of the component. They can be used by many different components actually. So rather than having them defined in the same file as the component, we can pull them out into a separate file. So here's the main program. Yeah, same as before. Here's the component. So now the component definition is in a single file that's only 20 lines long, and it's invoking these different reactive mixins. And then the mixins are defined in this separate file. Same as before, but at the bottom of this file, it's using this module.exports syntax, which is the node module format. So it's exporting an object that has, all these available on this object. And so in the component, we're requiring this mixin file, And then we're saying mixins dot margin convention, mixins dot x-axis, and so on. So this is how you can separate these reactive mixins into a separate file. So now this is a nice, clean starting point for actually making visualizations. So let's load some CSV data. So I've added this CSV file into the mix scatterplot data.csv. This is the iris dataset from the UCI machine learning repository. This is like one of my favorite datasets to use, when building these toy visualizations. Each record represents a flower, an iris flower. And it's popular for machine learning because it's easy to predict the class, like the species of flower, based on these different measurements of the flower, like the width and height of the petal, the width and height of the sepal. And I don't really know what that is. It's like some botany thing, some part of the flower. But that's what the data, that's what the data is. So let's see what this looks like. We can use d3.csv, and so this is like, straight up D3 patterns that are common in a lot of D3 stuff. So load the CSV file. This type function will parse each row of the file using this unary plus operator that parses a string into a number. And so, yeah, this function parses the data from strings to numbers. And then when we have the data, we can extract the component instance out of the chiasm environment using this chiasm.getComponent function that we saw before that returns a promise. And so you can call .then on the promise, which will then give you the component instance. And then we could say myComponent.data equals data. So we're adding this data property to the model of the component. And then in the component, here's my component. Here's some new stuff. My.when data and x column. So before I go there, in the main program, here's the chiasm configuration. We're passing some new stuff into the state of this component. The x-axis and the y-axis text is now, sepal length and petal length. See, now that's how it's appearing in the text of the actual axis labels now. And then there's these new things, x column and y column. And these are the object properties that you can access for each row of the data. Let's see, in the component, this is the stuff that's new. So when the data is present and the x column is present, and the x column is not equal to model.none, because x column is one of these things where we want to make it available in the configuration, but if it's not specified, it should have like no behavior. But it can't be undefined or null because that's like a strict requirement of chiasm because the stability issues. So it's like a quirk of chiasm. But so we're using model.none as the default value for x column and y column. So once the data is defined and the x column is defined, we say my.xScaleDomain, which is a property that was there before with the xScale mixin. We're computing the domain from the data now. d3.extent data, and this function accesses the value for the x column for each row of data. So this is another like common D3 pattern to get the minimum and maximum values for a particular column of the data set. And then the same thing for y. And so now you can see that these numbers have changed for the x and the y axis to be the actual, minimum and maximum, the actual domain for the data. So the next step is to make a scatter plot. Like this is the groundwork for a scatter plot. So here is the scatter plot. And the only new code to make that into a scatter plot is this right here. It's this like 10 lines where we require all the different properties that we need. The data, the x scale, the x column, the y scale, the y column, and the circle radius, which are all properties of the model. And then we use the conventional D3 patterns to visualize the data with these DOM elements. So select all circle, bind it to the data, use enter and exit, the D3 enter update exit paradigm for dealing with data that changes, data sets that become larger and smaller as you change them. And then here it's defining the x, y, and radius of the circles. And so the x is a function that gives the value for the x column applied to the x scale. And same thing for y. So this is a scatter plot implemented in a completely generic way. So you can change the configuration to change the data set. And the visualization component has no logic at all to do with the specific data set. So here's what a scatter plot looks like in this world. And right, so we had to write some custom code that loaded the CSV file. But this is such a common thing with data visualizations that this loading the data can also be made into a chiasm component. So here's one way that you could do that. A data loader component that you can set a path property. And this path property is scatterplot data. And I've added a file called scatterplotdata.json. Let me show you. So scatterplotdata.json has a JSON representation of the schema of this table. So it has the column names and the column types. So now that custom code that we had before to parse the specific columns, now all of that is in the file. We don't have to write custom code to parse the data anymore. And so let me show you the data loading component, what that really looks like. It's getting to be a lot of code now. Right, chiasm.plugins.data-loader. I've just put it in line here just to show you what it would look like. So it's a data loader where the path is model.none. And then when we have a path, we use d3.json to load the JSON file, which is the schema, the column types. And so we generate a list of the columns that are numeric by saying, filter the columns by only the ones that are of type number. And then this type function is the thing that parses each row of the CSV data, but it's written in a generic way now that uses this numeric columns that's parsed from that JSON schema representation. So it will parse the strings into numbers corresponding to the numeric columns. And then it will use d3.csv to actually load and parse the CSV file. And then when the data is loaded, it says my.data equals data. So my, in this case, is the instance of the data loader component. And see how in the configuration, the data loader component is set up with this path, right? So we have the data loaded into this component instance, but we want to have the data inside of this other one, this my component. This is the scatter plot. So I've written a bit of custom code here that just gets the two components, and then it says when the data is ready on the data loader component, pass it into the visualization component. So I'll just walk through this piece of code. So chiasm.getComponent myDataLoader. This is the thing that loads the CSV file. And then inside of that asynchronous call, chiasm.getComponent myComponent, which is the scatterplot. Maybe I should have renamed it scatterplot. But so this is the visualization component. And then myDataLoader.when. See, myDataLoader is it's a model.js instance, so we can use the when function even outside of the chiasm environment. So when the data is ready, set it to be the data property of my component. And this line is the same as what we had before. But this piece of custom code right here can also be generalized. Because all it's doing is saying, take a property from one component and set it to be a property of a different component, right? And so there's this other component called chiasm-links, and there's another component called chiasm-dsv-dataset, which is like a hardened version of that dataset loader plugin. And these all live under this chiasm project organization. So this chiasm links component introduces a domain-specific language for saying, like, whenever there's this property available on one component, set it to be this other property on this other component. And so the way this plays out, so here's the final example, like loading data the chiasm way. Like this is the way, sort of the way, I want to do it. So there's no custom code at all. It's all in the configuration. So the configuration has the layout, the visualization, the data loader, which is an instance of DSV dataset, which we're pulling in as from this node module, chiasm DSV dataset. This is the thing that loads and parses the file based on the schema, JSON, and then an instance of the links component or plugin where there's a single binding. So this is just the structure. So the state has a bindings property, which is an array of these strings. Each of these strings is an expression in this domain-specific language that says, in this case, whenever the data property is ready on the data loader, pass it into the data property of the visualization. So this is the loading data the chiasm way. So once we have all this infrastructure in place, we can implement different kinds of visualizations. So here's a bar chart, and I'll show you the only thing that changed is the implementation of my component. Now there is a new mixin for X scale ordinal. So this mixin is almost exactly the same as X scale linear, like we saw before, but it creates an ordinal scale with D3. And instead of using range, it uses range bands, which is a different function that's common to use for a bar chart. You can specify this X scale range padding, which I added here as a public property, of like 10% of the bar is used as the spacing between the bars. And that's an argument to range bands. But anyway, this is like a generalized version of an ordinal scale for the x-axis. And so that's being used in the component. And then most of this is the same, using the mixins for the axes. And then here's the part that renders the bar chart. Oh, the indentation's a little messed up. But it's basically, straightforward D3 code where, we're binding the data to rectangles. And let's see, we needed height here. So if you look at a D3 bar chart example, this is basically what it looks like. It's taken verbatim almost from the D3 bar chart example. So it's like for each data element, create a bar where the x is the value of that particular row for the x column passed through the x scale to give you an x pixel value. And then the width of the bar is the range band of the x ordinal scale. And then the y value, which is, remember, y0 is at the top. So y goes down from here. Yeah, it gets the value of the y column, passes it through the y scale. And then the height is the height of the inner rectangle minus the value from the y scale. So it's a little bit tricky, but like it comes up when you try to implement a bar chart in D3. So, and again, this is a generalized implementation. And there's still some things in the component that have to do with the scales. So like this is different from the scatter plot because this is an ordinal scale rather than a linear scale. So when you set the domain, no longer is it an interval of two numbers, but it's a set of discrete values. So this has changed to be data.map. So it applies this function to every element of the data array. So every element is a row in the table, basically. And so it extracts the value for the x column from every row in the table. And then that will be the x scale domain. So that's what we see here as A, B, C, D, E. So yeah, this is how you can make a bar chart within this world. And here's how you can make a line chart. Let's see, my component It's using a new mixin now, xscale time. And the mixin here is basically the same as the linear scale mixin, but instead of using d3.scale.linear, this is using d3.time.scale. And this is for dealing with dates. It has basically the same behavior as d3 linear, but it's for, dates. So if we go back to the component, right, so it's setting the domain to be the extent in both x and y, meaning the min and max from the data. And then it's using the D3 line. All right, so up here, we're creating line and path. Line is a d3.svg.line instance, which will generate these SVG paths based on data. And it's using this basis interpolation, which makes it a little bit smooth, so it's not these jagged edges. And then path is an SVG path element that has fill as none, because if you don't have this line, it will like make this big black thing, going across, and it just doesn't look right. It fills in the shape if you don't put this line. Fill is none. And then when the data is available, and the x scale and the x column and the y scale and the y column, whenever all this stuff is available, use the D3 line functionality to say that the x value for the line should be derived from this function, which is the same as before. It's getting the value for the x column out of the row and passing it through the x scale, and same for the y. And then it's saying path that attribute d. This is a SVG thing where the d attribute is this big string that is like, it defines this path. And this is generated by the D3 SVG line function here. So this is, again, like if you go to look at any D3 line chart, you sort of see this kind of code. But this is what it looks like, yeah, a line chart. And then I've made line stroke and line stroke width into properties on the model and given them defaults of like, okay, by default it's black and it's 1 pixel thick. And because these are public properties, you can change them in the configuration if you wanted to. So there's how to create 3 different visualizations in this chiasm environment. But one of the things that I really wanted to enable is putting multiple visualizations on the same page, which is not really that easy with D3, straight D3 if you try to do that. So in this next example, it just takes each of those components as is, and I renamed them from my component to bar chart, scatter plot, and line chart in the code. And then, so here's what the application looks like. It's exposing the plugins scatterplot, line chart, and bar chart right here. And scatterplot, line chart, and bar chart, we saw them all before. So if you look through, I just like in the let's find one of those barchart.js. So I just said, function barchart, module.exports barchart, and I just changed my component to barchart. I just copied it from all the other examples. And then, so I want to just show the configuration, what it looks like. So here's the layout configuration. So at the top level, there's a vertical split where the first element is a horizontal split with, my bar chart and my scatter plot, like that. And then the thing on the bottom is my line chart. And this size here, so I added the size property in the layout so that you can change the relative sizes of things. So like the default size is 1 for everything. And that means if you split something horizontally 3 ways, each thing gets exactly 1/3. They're the same size. So by making the size of this node in the layout tree 2, and this node is the thing on the top of the vertical split, So that means the top vertical split gets 2/3 of the space. And then the line chart on the bottom gets 1/3 of the vertical space.
Oriented horizontally, right?
Yeah, it's confusing to think about. Like when I say vertical split, I mean like the box is like this and it's split this way. So there's stuff on the top, stuff on the bottom.
So it's laid out vertically.
Right, laid out vertically. But yeah, the split line.
Horizontal.
if you think about the split as the line that splits it, then that line is horizontal. That's true.
That's what it's doing here. In the first section, you're saying the orientation is vertical, which means children and my line chart are arranged vertically.
Right. Yeah, this thing's on the top, this thing's on the bottom in a vertical arrangement. Yeah, yeah. Right. This is the first
Yeah,
child.
that has horizontal orientation.
Yeah. So inside of here, it's the horizontal split between the bar chart and the scatter plot. Yeah.
You still have the size on top. It's confusing because the size 2 doesn't apply to the horizontal orientation.
That's true. Yeah, the size applies to this node in the tree. And this node has child nodes of my bar chart and my scatter plot. Maybe I should have organized it like this.
Here we look at the name. Time is split between name and.
Is that a size or is it a weight, like the coefficient?
Yeah, it's more like a weight.
It's a weight.
It's more like a weight, really, because everything has default weight as 1.
Right.
And if you change it to be 2, then it's double that. So because this is 2 here, then the thing on the top has weight 2. The thing on the bottom has weight 1 by default. So the total is 3. So it gets split by 3, and then the top
I
thing.
have enough gray hairs that 20 years ago you would have used the word weight
Weight.
for a layout engine that size.
Maybe I should. Maybe I should change it. It's not too late. If you want to assign size to an intermediate node that has children, you do it like this. But if you want to assign size to an individual plot, like this, here's 2 instances of the line chart. And then the way that you specify size is totally different. There's a sizes property that's a sibling of the layout property, where the key, focus line chart, is the alias for the component. And this could have been 2, but I have an object where there's size 2, because you can also have something in here called hidden. And if hidden is true, then this object is excluded from the layout. And it's just a quirky way, like I want to refactor this and make it cleaner, but this is how it works right now. But yeah, this is basically specifying that the top one is twice as big as the bottom one. Yeah. But let me finish covering this configuration. So the layout here is like this, and then we have, these 2 components define the line chart. The top thing is the thing that loads the data for the line chart, and the bottom thing is the line chart itself. And this has a bunch of tweaks, like I didn't want to use the defaults anymore for the margin and the label offset because I wanted to fit everything in this small space, So it just shows you how you can take anything that has a public property and start manipulating it at this level, in the configuration, in the application configuration. And then the same thing for these other visualizations. Oh, and then the links plugin became a little bit more complicated. There's now 3 things that just pass the data from the respective data loaders into their corresponding visualizations. So it's loading actually 3 different CSV files that are each defined with their own JSON schema file. And then the mappings of the X column and the Y column are just defined here in the configuration. Yeah. So this is how you can put multiple visualizations on the page. And I mentioned that with this project, I want to be able to link visualizations together with interactions. So here's an example where you can brush in one chart and it sort of zooms in. Well, anyway, this is a focus plus context with brushing. And the line goes outside of the box there, and you can fix it. I just didn't put it in because it would make the code a little more complicated. Let me just show you the code where it adds the brush here. So down in the line chart, and this X brush is implemented as another mixin, another one of these reactive mixins. So you give it the model and then the group element, which it will add itself to. So if we take a look at this X brush thing, here's what it looks like. So it's creating a D3 brush instance. It's creating a group element to hold the brush, and it's giving it a class of brush, so we can use CSS to style it. And then we're adding a public property, is the brush enabled? And the default is false. So notice that on the top line chart, there's no brush available, because I've only set brush enabled to be true on the bottom line chart in the configuration. So brush.on brush, so this is a D3 event, like whenever you actually move the brush, it will call this function and say my.brushIntervalX equals, if the brush is empty, set it to be the domain of the scale, so the complete range. Otherwise, set it to be the extent of the brush. And we can see that behavior if I click the brush off, then this piece of the code is getting executed. You know, and without this piece of code, if I remove the brush, it would just like stay there how it was before, you know, or have some other weird behavior. So when the X scale and the height is defined, here's where the brush is being set up with the scale. You know, so when the scale is ready, we're setting the X scale of the brush to be that scale. And then we're using this call pattern, this D3 call pattern, to like instantiate the brush. And what this does is it gives you this behavior of when you hover over it, you see this the cursor. The cursor is this nice X crosshair thing, and that comes with calling this line of code right here. And then this piece sets the brush to be vertically a constant size. And because the brush group is inside of the G element that has to do with the margin, that's why it aligns with the axis. But we have to do this work to set up the height and a fixed y equals 0. And this is not necessary if you have a two-dimensional brush, but since the brush is only going in one direction, we have to set the height of the brush rectangle sort of manually. And then this chunk of code here deals with turning the brush on and off. And so this lets you set the brush enabled property at runtime. And so if you set brush enabled to be false, then it will remove the brush from the DOM. And, well, it'll remove it in any case, right? And then if brush is enabled, then it will add it back to the DOM. If brush is not enabled, it will just remove the brush from the DOM. So that's why we don't have any crosshair behavior on the top one, because I set it to be enabled as false. So let me show you how these two charts are linked together in the configuration. So there's the main JavaScript, right? There's the layout. It says focus is on top, context is on the bottom. And this is a pattern in data visualization that comes up over and over again. It's focus plus context. Overview first, zoom and filter, and then details on demand. That's like this, saying in these visualization communities. So here in the links plugin, the data loaders are the first two lines, but then this last line says, whenever the brush interval X property changes on the context line chart, then set the X scale domain to be that value on the focus line chart. So this is how you can use this links plugin to do linked views. And so you can pass properties around, it's a general thing, right? So for this to work, the brush interval X and the X scale domain have to understand the same data structure, which they do. It's an array of the minimum and maximum values. So that's why this works. And you could get this to work if you had added a clip path. And so I've got this other example that actually does that. That's like slightly more complex. But it works.
So to get a clip path, can you do that on a G element?
Clip paths are something I don't feel like I completely understand. It's
The last time I looked, a G element doesn't clip, an SVG element does.
yeah, I came across this issue, and I think what I ended up doing is I discovered that you can actually have an SVG element inside of an SVG element. Then the clip path
And I think
works.
the printing prints properly on nested SVGs.
Hmm.
You have separate SVGs on the
Right, exactly.
Okay.
Yeah, so I ran into all those issues, and it was complicated to solve, but I got it working in this example. So if you wanted to, I'll leave that as an exercise for the reader. But that's the basic, organization of chiasm and how it lets you create linked views. So I want this to be like a very open-ended project where people will contribute their own components, and we'll have this wonderful ecosystem. But it's not there yet, but it's just getting started. So that's all I got. Thanks for listening. And I'm happy to take questions if you want to hang around. Yeah.
What do you see as like the future steps for this project? Like what do you see like things happening in the near future that you would like to know about?
So there's a bunch of issues. I want to add an SVG download button, so you can get the SVG data out. Here's the one that I see as like the future. I want to enable all these different kinds of linked view patterns. So we saw one pattern of linked views, which is focus plus context with zooming. But there's also other kinds of linked views. Like I got one working with cross filter. That was one goal, and I got that working. And I want to add an example that does this Voronoi overlay to do really nice picking. So like hovering on the points of a scatter plot using this Voronoi overlay, that could maybe like trigger a slice of the data based on that to show in some other view. So I want to explore this space of linked view patterns in the project, and then enable all these different linked view patterns where like one thing slices the data. Like one cool example, is it here? Yeah, the line chart in choropleth. This is an example I want to recreate in chiasm. I made this a long time back with just model.js. And this is like when you hover in the line chart, it will filter the data used as input to the map. And then when you zoom in the map, it filters the data used as input to the line chart. So you can see these really stark events like the Rwandan genocide when you zoom into the map. And also there's this, the coloring of the lines whenever you hover on a line. So if you zoom out and then you hover over like India, you can see, okay, India is the second largest country, and then China is the largest country. And also legends. I want to have, figure out how to have separate chiasm components for legends. So like a color legend, I want to make that work, and also make the color legends maybe interactive. So if you hover over this one, like all the ones that are in this range would highlight in the visualizations, that sort of a thing. And also I want to sort of set up a repository of data sets. And I've started on it, but it's not quite there yet. I've got all these different CSV files, and I want to make it into like a coherent thing where each one has like its own schema representation. And you can use chiasm to sort of like fly through the space and like navigate different data sets and things like that. What else? This is the sort of thing I'm working on at Alpine, where we're building these like lenses that should work on arbitrary data sets. And so this is like this is introducing a component that does aggregation into histograms, so you can like change the histogram size and like change the orientation, change the column interactively. So I want to go more in this direction. This is using an AngularJS UI, and you can like change the data set to be the adult data set, which is a sample of the 1990 census data. But yeah, I want to make more things like this and solve these issues. These have been really a pain to deal with. Like, I don't know how really to deal with these issues in a general case where like these things are overlapping, and then if you make it horizontal, like the tick mark labels overlap with the axes. So I want to solve these problems in a general case. I'm thinking of making it so that you can like drag and like edit the margin interactively. So yeah, that's sort of what I want to do, like have the sea of data and make chiasm a tool that people can really use in practically speaking, to build visualizations and integrate these interactive visualizations into products that maybe hook into like proprietary APIs. Yeah, that's sort of the direction.
Separate your tasks, your plan into whole new features and stable API.
Right. Yeah, I mean, that's a great question. Like, when will the API be stable? So I want to show you one thing. So in the chiasm homepage, there's this list of examples. And these examples don't have a thick black border. And starting with this example, they do. And this example is the first version that uses the v0.2.0 API. And this I think is the last big refactoring I want to do of the core chiasm runtime. I mean, the actual components will probably change, like the layout plugin might change, and so that the layout plugin is not totally stable yet. But I feel like this is pretty stable. So all these examples with the black border are using this 0.2.0 API. And I feel like that's fairly stable, but like, yeah, no guarantees. I mean, it's a young project. It's like 7-8 months old. But I think this is a pretty stable API. But like, yeah, it won't change too dramatically. So like, I would encourage you highly to start building start building on it. Yeah, start building on it as soon as you feel ready. Yeah.
We're close to time, so one more question if anybody has. Thank you very much.
All right, thanks a lot. Thanks a lot.
Small token of